So as we move into what's called trigonometry, this kind of blends algebra and geometry together. Um, so when we get into trigonometry, we have these special, what we call trig functions, if you will. Uh, so there's sine, cosine, and tangent is what we kind of start out with. Sine, cosine, and tangent. Now, what happens is sine, cosine, and tangent create ratios depending on what angle we're talking about. So if we're looking at angle A, we have, if we're talking about angle A, this side 11 becomes what's called the opposite side. The side next to it, notice how we have this right angle here. So the 11 becomes the opposite side. The 60 becomes the adjacent side. And then opposite the right angle, this is referred to as the hypotenuse, or we abbreviate HYP, hypotenuse. So again, so we have these three trig identities, and a lot of times the sine of angle A is going to be defined by the opposite over the adjacent. I'm sorry, over the hypotenuse, I should say. The cosine of angle A would be the adjacent over the hypotenuse. And then bring this down a little bit more. The tangent of angle A, so we use these abbreviations tan. So tangent of the angle A is going to be equal to the ratio of the opposite over the adjacent. So to memorize this stuff, we use the phrase, we'll put it up here. So, ka, toa. So kind of stands for sine is equal to the opposite of the hypotenuse. Ka stands for the cosine of an angle equals the adjacent over the hypotenuse. And toa is the tangent is equal to the opposite over the adjacent. So we have these three ratios. So the sine of an angle, since we're talking about angle A, the catch is if we're talking about angle A, then the 11 becomes the opposite, the 60 becomes the adjacent, and the 61 becomes the hypotenuse. So for this problem right here, the sine of angle A would be 11 over 61. If we're talking about the cosine of angle A, then we would have used 60 over 61. And if we do the tangent of angle A, that's going to be the 11 over the 60. Now, if I changed angles, so instead of talking about angle A, we're talking about angle B. So again, we have to be using the adjacent, the acute angles, I should say. So we don't deal with the right angle. We talk about the acute angles here. So we're only going to be involving the A and the B. So if I want to do the sine of angle B, notice that things have switched. If we're talking about angle B, we now have the 60 becomes the opposite. The 11 becomes the adjacent, but the 61 is still the hypotenuse. So if we're dealing with angle B, notice that our ratios change a little bit. So now we're going to have 60 over 61 for the sine of angle B. The cosine of angle B would be the adjacent over the hypotenuse. That would be the 11 over 61. And then the tangent of angle B would be the opposite over the adjacent, so that'd be 60 over 11. So these ratios can be used to determine what the angle is at this spot. So we'll get more into that later. So right now they're just talking about the ratios. So this phrase here, so, ka, toa, is the three that we use for sine, cosine, and tangent. And that helps us generate these ratios without a whole lot of effort.